Buenas tardes a todos. Yo tengo enorme gusto y honor de presentar la quinta conferencia magistral del TEMBI 10 a cargo de Ljerka Jukic. Ella es profesora asociada de la Escuela de Matemáticas Aplicadas e Informática afiliada a la Universidad de Osijek, Croacia. El enfoque principal de su investigación en el campo de la educación matemática radica en las áreas de formación profesional docente, la utilización efectiva de los recursos curriculares y en el diseño de tareas matemáticas. Ella es la autora de libros de textos de matemáticas diseñadas para la educación secundaria en Croacia. Participa activamente en dos proyectos: desarrollo profesional del profesorado en la función de mejorar los resultados de aprendizaje de los estudiantes de secundaria en Ciencias y Matemáticas, 𝒐𝒏𝒄𝒐𝒏, financiado por la Fundación Croata para la Ciencia, y aprendizaje matemático basado en juegos, 𝒂𝒓𝒂𝒂𝒊𝒄𝒂𝒍, financiado por la Unión Europea. Ljerka Jukic desempeña un papel destacado como organizadora de la Conferencia Nacional de Docente, Enseñanza Innovadora de Matemáticas, así como el coloquio científico Matemáticas y Niños. Colabora estrechamente con la Agencia de Formación Docente en el desarrollo y administración y calificaciones de exámenes para profesores de matemática. Ella es miembro del Grupo Internacional de Psicología de la Educación Matemática, PME, la Sociedad Europea para la Investigación en Educación Matemática, 𝒎𝒏𝒄𝒐𝒖𝒓𝒂𝒐𝒍, la Sociedad Croata de Matemática y Sociedad Matemática de Osijek, UM. Adelante, Ljerka.
Thank you, Professor Slisko, for this nice introduction. I did understand something in Spanish. So we can start with the presentation. Okay, I see you see it. So the title of my talk will be How Can We Encourage Creativity, Mathematical Creativity in the Classroom? So why creativity? The 4 C's, collaboration, critical thinking, communication, and creativity are recognized as essential 21st century skills, and enhancing the development of these skills, according to OECD, is among the best approaches to prepare students for jobs that do not yet exist, for social challenges, or utilization of technology that has not been invented yet. Mathematics educators and researchers recognized creativity as essential skill in mathematics education as well. And with that in mind, in the last decade, area of research in mathematics education started to examine mathematical creativity more than in previous decades. It is impossible to overstate the importance of mathematical creativity as a means to an end or as an end to itself. Why? Mathematical creativity is important not only as a skill, as 21st century skill, but in the classroom is also very important because creative individuals have advantage. They can apply what they have learned in a new context and create new connections between different types of knowledge and skills. Before we start talking about mathematical creativity, we should explain, or I will explain something about creativity. There is not unique definition of creativity. Creativity has been studied from various points of view, philosophical point of view, artistical point of view, psychological, psychometric. So, for example, creativity can be understood as combination of divergent and convergent thinking. So convergent thinking would be exploring variability, and divergent thinking would be producing some variability. Then we have this psychometric approach developed by Torrance, which based definition of creativity on 4 components: fluency, flexibility, originality, and elaboration. I emphasize Torrance because some of these components will be used later in the talk. And Torrance developed a battery of tests for testing creativity. So there are many definitions of creativity, and a review of the literature on creativity that was conducted in 2004 showed that novelty or creation of something new is the key component in all definitions of creativity. So usefulness and novelty are 2 components, and their combination, which form the basis for academic talks about creativity. There is also important issue that is still going on, and this is connected with transferring creativity into other domains. So is creativity transferable skill or not? In mathematics education, most researchers agree that mathematical creativity is not transferable skill. So let us see what mathematical creativity is. So as in case with creativity, mathematical creativity also does not have a definition that is accepted or unique definition. For most, mathematical creativity is associated with professional mathematicians because their work requires solving novel and complex problems. So on one hand, we can see creativity, mathematical creativity, as capacity to develop practical solutions to mathematical problems through the use of modeling, or capacity to produce original and novel work. Okay, this is how mathematical creativity is seen in the context of mathematics, pure mathematics or applied mathematics in scientific profession of mathematics. But mathematical creativity in school is a bit different. It's different than creativity and is differently considered than creativity of professional mathematicians. And of course, because children in school cannot produce something globally new, but we can assess mathematical creativity in relation to students' prior experience and in relation to performance of other students with similar educational background. So, creativity in school is usually based, or definition of mathematical creativity in school is based on Haluk's idea as capacity for divergent production within mathematical situations. So, this is a starting point of many definitions of mathematical creativity used in various studies in mathematics education. And mathematical creativity is, of course, different than creativity of professional mathematicians. And Lykin asserts that this creativity should be considered as relative creativity, unlike absolute creativity, which is connected with global discoveries. And this is similar as big C and little c creativity of Chick and Mikhail, philosopher who talked about what actually creativity means in ordinary life. There are 2 most advocated strategies or contexts for fostering and developing mathematical creativity in school, and those are problem-based learning and problem posing. And in this context, open tasks fit nicely. Open tasks are usually emphasized as a tool which can be used to promote divergent thinking and creativity in classroom. So, what are open tasks? Open tasks are problems, mathematical problems of various types. Those open task problems can be investigation problems, problem-posing task, real-life situation, projects, problem fields, problems without questions. Or we can think about open task as umbrella class or overarching category, where we can put all similar tasks that have open starting point situation or open goal situation or combination of both. So tasks that have open starting situation and open goal situation. Open tasks present creativity-directed activities because they ask for mental flexibility and provide multiple opportunities for producing novel ideas. So in this context, we will examine two kinds of open tasks. Multiple solution tasks and multiple outcome tasks, which belong to category of problem solving. And if there's time, enough time, I will present you category of problem posing as another category of open task, which can be used to foster mathematical creativity in classroom. So what are multiple solution tasks? Multiple solution tasks are tasks with explicit requirement to be solved using different methods. Multiple solution tasks introduced Lykin, who developed also model for evaluating mathematical creativity with multiple solution tasks, but she also used this multiple solution task or MSTs to give operational definition of creativity in school context. So, using Lykin's words, mathematical creativity is mental flexibility to solve particular problem with multiple methods, to implement strategies from various mathematical domains, to produce insightful solutions to a problem. As I said earlier, Lykin used these MSTs to develop a model for evaluating mathematical creativity. As you can see on the screen, she had three components, or she has three components in this model: originality, fluency, and flexibility. And I want to remind you that these components were seen in Torrance psychometric tests. If you want to measure or assess creativity, mathematical creativity of students, you have to have some categories which are defined in a manner that you can use it practically. So what is fluency, or what is flexibility, or what is originality in this context? Fluency would be the number of correct or appropriate solution methods used for solving MSTs. Flexibility, it's number of different solution methods that student or person uses while solving particular MST. And originality is assessed how rare this solution method is among group of students to which student belongs to when solving MST. Lykin also developed appropriate scoring scheme, which can be used also not only for research purposes, but also for classroom experiences. I will present you now one example of MST. This is a task that can be found in various textbooks, for example, high school textbooks, tutoring materials, online tutorials, then materials for exam preparation. And it is very simple. The right triangle has sides with lengths 6, 8, and 10. And the question is, what is the length of the altitude to the hypothesis in that right triangle? Usually, this task is used in this way. There are no requirements for solving it with multiple solution methods. However, this task has 9 solution methods which can be solved with, and it's classified then as MST. Just a moment. So, I and my colleague Professor Slisko, we converted this task into MST, and we use it in a study to examine mathematical creativity of first-year undergraduates. So let's see how that happened. Before you start assessing mathematical creativity of your students, using MSTs, you have to write down all solution methods which can be used for particular task. I apologize, I was sick several days before, so my voice is a bit rough. So actually, our MST has 9 solution methods, and you can see them on the screen. 8 solution methods can be thought as conventional solution methods, while this last solution method is unconventional one because it uses coordinate geometry. So when you use MST in the context of classroom, you have to prepare all possible solution methods that your students will probably use, so you can assess their creativity. Here are also some terms which are important in this context. Expert solution space, that are, this is all expert solution methods. Then we have individual solution space, set of solutions which is generated by a person or a student in this classroom situation without the assistance of another person. And then we have a collective solution space, which represents solutions or solution methods generated by a group of participants who are solving particular tasks. Okay, so we converted the altitude task into MST. And what was our main objective? To examine mathematical creativity of first-year mathematics students. Usually, in various studies which use MST, there are some kind of interventions where students practice MST, various kinds of MSTs, and then researchers give them some other MST, and then they assess their mathematical creativity. But here we wanted to assess creativity in genuine situation, so for the students who came to the university. So participants were first-year mathematics undergraduates, and they got questionnaire under calculus lecture. It was this altitude task and also some other questions, like their attitudes toward the MSTs, and if they used MST in school and where. What important things can students conclude about learning mathematics if they encounter problems that can be solved in 2 or more ways? So we had 70 first-year mathematics undergraduates, and amongst these 70, 61 students presented their solutions. Others didn't want to participate as much. And of course, this was voluntarily. So we are very grateful that even these 61 students wrote down their solutions. Before we started to calculate their or measure their creativity, we adapted scoring scheme from Likhe. And this scoring scheme is connected with all those components we saw on the screen before: fluency, flexibility, or originality. So we examined individual solution space of each student and so if the student used one or two solution methods, if these solution methods are similar or if they are different. So if they are different, they were awarded 10 points. If they are similar, then they were awarded 1 point. If they are almost identical, then 0.1. Originality was scored similarly, and Lycan used arbitrary condition where solutions are original if they appear in less than 15% of participating students. So we calculated flexibility, fluency, and originality for each student, and then we calculated mathematical creativity using those scores, using these formulas on the screen. So what we have found in students' solution spaces. In collective solution space, we have found 8 out of 9 solution methods. Pythagorean theorem was the most used method. Then right triangle area was the second most used method. And then there is Heron's formula. We have also detected other solution methods like using similar triangles to calculate the altitude, or trigonometric ratios. And I will show you another trigonometric ratio combined with similar triangles or geometric mean theorem. All these solution methods are methods that are learned in Croatian high school, and it is something that student who comes to university must be aware of, because they have to pass graduation exam in order to enroll into university. So there is also one solution method which I didn't put on the slide, and it is using law of sine or cosine. But the student who used it didn't produce correct solutions. So out of 9, we have found 8 solution methods. So when we calculated their creativity, we first saw how flexible the students were, and we scored their originality. It is interesting to see that which method was used as first or second solution method. And here you can see in the table on the screen that Pythagorean theorem was the most used solution method, and right triangle area, and other methods appeared less. So what also you can see from this screen is that not all students used 2 solution methods to find the altitude. Namely, 41% of students used only 1 solution method. Of course, this reflected on their results. And here you can see scores on their mathematical creativity. This score of 202 means that these students have high level of creativity. 100 means average, and everything below from 1 to 40 is, let's say, poor. So let's move to students' opinions, and then later I will comment our utilization of this MST. So we asked students what they think about a task that asks for several solution methods, and they all were very positive. But they indicated that the requirement for multiple ways of solving tasks was not a regular part of their mathematics lesson in school. Most students were positive, and here I would emphasize a statement of one student who said, "For years now, I have been saying, even to my teachers, always, there are several ways to solve a problem." And this statement shows his frustration with a teacher who only wanted his or her way of solving, only using one method. Students who showed negative attitude toward MST were influenced by their teachers' actions in the classroom, which means that they said, I never had need for more than one solution. I'm happy with using solution method my teacher provided. In this study, we asked students for only 2 solution methods because we did this study during calculus course, and we were afraid that if we asked students, okay, use all solution methods you can think of to solve the task, that they would be not so keen on participating in the study. So this is one limitation of our study. But it is possible also to assess and foster creativity with 2 solution methods. Those students who produced only one solution method, of course, showed their level of creativity, but maybe those students who had 2 solution methods, maybe they could produce more. So this will be something that we'll examine in the next study. But even with these 2 solutions, it is possible to estimate or evaluate creativity of students in a way if their second method deviates from conventional methods more. But you have seen on the screen in several slides before that the most used methods are Pythagorean theorem and right triangle area, and that many students did not deviate from these 2 methods. MSTs are very fruitful in domain of geometry and can be used there. But some studies like Tabach and Friedlander used it in algebra context, where they gave students algebra task and asked them to solve it in multiple ways. So it's possible to use this kind of MSTs or multiple solution tasks in other context than geometry. Okay. Let us now examine how can we foster creativity using multiple outcome tasks. So what are multiple outcome tasks? Multiple outcome tasks are tasks with the requirement to generate as many answers as possible. In MSTs, we had as many as solution methods as possible, and here we have as many answers as possible. Researchers who use multiple outcome tasks claim that using this task is beneficial for mixed ability classes, because in a way MSTs have pre-designed creativity or embedded potential, because we in the beginning we create expert solution space and we know which solution methods should be used. But on the other hand, in context of multiple outcome tasks, we examine products or answers in the group of students who are using this or solving this task. So creativity is examined according to that group. There is also a model for evaluating creativity, which also uses originality, fluency, and flexibility, the same components as used in MSTs. Of course, fluency is the number of correct answers for the task. Flexibility is number of different categories found in a student's work. This is connected with these outcomes different if we give multiple outcome tasks in one class, and in other class we can get different results. So in that way, we assess students with multiple outcome tasks. So first we have to examine all solutions that students produce and categorize them. And then to determine flexibility, we then examine individual solution spaces and determine how the number of different categories in students' work. And here originality is similar as in Likens model, based on frequency and insight, and it's regarded that answer that is present in 15% or less of the solution is considered original. Let us now examine one or two examples of multiple outcome tasks. So these two tasks are taken from study of Mollad and Associates. The first task asks to draw as many different shapes as possible with an area of 15 units. And the task number 2 says that you should draw a polygon on geoboard with an area of 2 square units, such that no two polygons are congruent to each other. So the first task has infinitely many solutions. And in this study, students did calculate areas of certain shapes, or they counted the number of squares or units they used on a grid paper. Some students generated almost 50 shapes, but of course, not all were appropriate. And this is a criteria. We have to establish what is appropriate or not. And in the second task, researchers found 33 different solutions. 9 were classified as original. Most figures were pentagons or hexagons. And of course, there were some non-convex figures among student solutions. So here I present you also student solutions on the screen. And here you can see that students had many convex, and you can see one non-convex shape or polygon, and this is a deltoid in the third row. So MSTs and multiple MOTs, multiple outcome tasks, and multiple solution tasks, they belong to the problem-solving category. And here we also have problem posing as a means to foster creativity. Multiple solution tasks are the most used among all these tools or tasks to promote creativity. Multiple outcome tasks are used less than MSTs, and problem posing are used the least. Multiple solution tasks are used from 2009, while later researchers started using other categories of open tasks to foster creativity. Multiple solution tasks are used in large studies to examine a relationship between, for example, general creativity, mathematical ability, and giftedness. They are used also with eye tracking devices to examine creative processes and where illumination is situated in this process. Multiple outcome tasks are used mainly in collaborative studies, and the results of these studies showed that students who collaboratively solved multiple outcome tasks were able to find non-conventional or unanticipated solutions, unlike students who worked alone. And also strategic flexibility was better in collaborative setting, and also strategic fluency. What are problem-posing tasks? Problem-posing tasks are tasks where you have a situation or some conditions, and you have to pose problem that meets these conditions or requirements. So, problem posing requires participants to formulate problem statements that are novel to the poser based on a given set of conditions. And here we have several situations where we can, or how can we pose a problem. They are type of open task, definitely, because for a given condition or constraints, you can pose various problems. And it is also important to distinguish problem-posing situations that can appear: free, semi-structured, or structured. In free situations, you create problems without constraints or over a broad range of situations. In semi-structured situations, you complete some open scenario. And in structured situations, you have many conditions and many constraints. And as you will see, it is difficult in such situation to promote creativity. So problem posing is not only good for promoting mathematical creativity, but it also can be used for the teacher can use problem posing to examine students' knowledge, because student has to have a good knowledge of concept he will use in this problem posing. And also the teacher can assess prior students' knowledge, because during problem posing, students have to use this creative thinking and also have to be flexible to pose various problems. So how can problem posing be used in promoting mathematical creativity? If we put a requirement to pose as many problems as possible for the given situation, then we convert this problem posing into creativity-directed activities. Of course, semi-structured or free situations foster mathematical creativity more than structured, and Bonotto and Del Santo empirically examined this claim and came to this conclusion that, of course, structured situations do not foster mathematical creativity as much as these free or semi-structured situations. Of course, there is a model which can be used to assess mathematical creativity in problem posing, and similarly as in the MOT's case or MST case, also there are three components: fluency, flexibility, and originality. Fluency, the number of posed problems, it's in the number of posed problems. Flexibility, diversity of posed problems, and originality, similar as in the models before, rareness of the posed problems. However, Van Harper and C. Raman proposed boundary that if the problem is original, if it's not posed by more than 10% of participants in the group. We had in MOTs and MSTs 15, but 15 or 10, it's similar, it's not that great difference. One criteria or indicator of creativity could be also student evaluation of suitability of their created problems, because not all problems are valid. Not all posed problems are good, because sometimes students can pose problems which don't make sense. So we also had to have some criteria which problems are valid or which problems are good problems. Let's see some examples of problem posing. In task 1, there are 10 girls and 10 boys standing in a line. Make up as many problems as you can that you use the information in some way. And the second, last night there was a party at your cousin's house and doorbell rang 10 times. The first time the doorbell rang, only one guest arrived. Each time the doorbell rang, 3 more guests arrived than had arrived on the previous ring. How many guests will arrive on 10th ring? Explain how you found your answer, and B, ask as many questions as you can that are in some way related to this problem. These two tasks are taken from a study by Yuan and Sir Raman. And let's see what the students or how they solve these tasks. Task 1 represents a free problem posing situation. Here students were very creative and posed problems using arithmetic or combinations and permutations. And the task 2 is structured task, and here students posed very trivial problems, like involving the total number of people and involving number of things. So you can really see that difference between open or free problem-posing situation and structured is great in the way that free problems encourage students and promote mathematical creativity more than structured situations. Although number of studies which used problem posing is smaller than number of studies which used MSTs, they all have these unambiguous results, which show that problem posing is indeed beneficial for fostering mathematical creativity or encouraging mathematical creativity. For instance, study by Dan Santo, which she conducted in 5th grade, showed that students by the end of 5th grade are able to distinguish between mathematical problems and tasks that are not problems, and they can develop this mathematical creativity. Problem-posing situations or creativity was using problem-posing situations can be also given to the students in primary school, and not only primary but middle and high school. Van Harpen and Sri Raman used problem posing in high school, and they developed these rubrics using the model, but Bitzer use problem posing situations in primary school and adapt those rubrics for primary school children. Of course, creativity and these open tasks have influence also not only on cognitive students' characteristics, but also on affective. And these are good characteristics. Students experience competence and autonomy because they have multiple opportunities to solve some task or to produce various answers. Students' interest increases compared than to traditional tasks. Students also have higher self-efficacy if they participate in creativity-directed activities, and using open and ill-structured tasks can increase students' positive attitudes toward mathematics and also beliefs about utility of mathematics. However, in today's educational context, which emphasizes accountability and measurability, educational policymakers use data from standardized tests not only to assess student progress, but to evaluate the quality of teachers and educational settings. And in this dominance of evaluation, mathematical creativity is a bit marginalized because it's not directly measurable by standardized tests. So in this context, it is important to nurture and promote methods of learning that exceeds standard measurement. And in conclusion, this means that teacher is very important in a classroom. Teacher plays a significant role in fostering mathematical creativity because the teacher choose activities, put activities into action, and structure the work that students do in the classroom. So what is my recommendation after this talk? Many school textbooks already contain open tasks, and research has shown that these open tasks are present to some extent, but that they don't usually ask for two solutions, more solution, or more solution methods. So this would be the first step. The teacher uses open tasks already present in the textbook and asks students, okay, solve it with two methods or provide more than one answer. So this is the first step for promoting mathematical creativity. So this is all from me. So thank you.
Gracias, Jjerka, for this very interesting conference. I will be waiting to translate the questions.
Okay, do you also consider solving standard mathematics problem as an activity that requires creativity? Yes. Solving mathematical problems, not tasks that are for practice, it also promotes mathematical creativity. But to many students, solving mathematical problem is difficult, especially for students that have a low ability. Open tasks do not have to be necessarily so problematic in terms that students have to have this cognitive architecture built, but also lower achieving students could pose, for example, 2 problems, or they can find 2 answers to some multiple outcome tasks. But yes, solving mathematics problems is creativity-directed activity because it requires flexibility and connecting various pieces of knowledge or informations.
¿Alguna otra pregunta, por favor?
How can I assess creativity in the solutions of my student works? Well, it depends which type of task are you using. If you are using multiple outcome tasks, then you have to examine all solutions from all students and categorize them, and then see which solutions are original. So this would be like one category, and examine flexibility as another category. So only like can combine these components into scoring scheme. Other researchers, they separately examine originality, fluency, and flexibility. So the first step is examining all students' work.
¿Otra pregunta?
Well, quantifying fluency. Well, fluency can be quantified, but flexibility is dominant component, and originality, which is assessed in this kind of problem posing. But there are also other models from, for example, Singer and Dvojka had different model for assessing problem posing. So maybe problem posing fluency is wrong category in some way. So there are not unique models. You have to decide by yourself what do you want to assess. If you want to assess fluency or flexibility or originality. Quantifying fluency, yes, I quantified fluency in my students' work, but this is not something that influences so much on their creative outcome. I personally have not done research on transfer of creativity to other areas of life, but I can quote some research. For example, some researchers claim that creativity can be transferred from, for example, from drama to songs, but mathematical creativity, not so much. This is the general attitude of researchers in mathematics education community. Thank you for the question.
Esto Ya no es una pregunta, es... Gracias. ¿Alguna otra pregunta? ¿Algún comentario?
So thank you very much, and I hope I wasn't too fast. I speak Spanish only from telenovelas, but not as good as speaking for the conference.
Si no hay más preguntas, entonces nos queda agradecer a la doctora 𝒎𝒂𝒕𝒊𝒄𝒂𝒍 por su interesante conferencia y no sé si se va a proyectar la constancia para su participación. Muy bien, entonces cerramos la última conferencia del TEMBI y estamos en espera para la inauguración del TEMBI. Gracias. Hvala, Ljerka.
Hola, buenas tardes a todos. Esperamos el ingreso de la doctora Estela. Esperamos que se quede también el doctor Slisko para hacer la clausura. ¿Están ya por aquí? Hola, Estela.
Buena tarde.
El doctor Slisko se desconectó, Sergio. Es que Sergio nos está apoyando en los controles. Hola.
Sí, ¿qué tal, doctora? Sí, ya se desconectó.
Ok. Bueno, entonces vamos a proceder nosotros a hacer la clausura del evento, pero antes queremos presentarles el libro del 9º Taller Internacional Tendencias en la Educación Matemática basada en la investigación, que como ya es costumbre, lanza su convocatoria para los capítulos del libro en diciembre, antes de salir de vacaciones. Después pasa por el proceso de arbitraje y finalmente el proceso editorial. Esta vez fue editado por la editorial de SOMIDEM, la Sociedad de Investigación e Innovación en educación matemática, y la edición estuvo a cargo de la doctora Estela Juárez Ruiz, aquí presente. Yo también participé, y el doctor Apolo Castañeda por parte de la SOMIDEM. Entonces, le doy la palabra a la doctora Estela para que nos haga la presentación del libro, y después intervendré yo también para participar.
Muchas gracias, doctora Lidia. Pues es un gusto poder presentar a ustedes el libro Tendencias en la Educación Matemática 2023, el cual fue editado. Las editoras son una servidora, Estela de Lourdes Juárez Ruiz, la doctora Lidia Aurora Hernández Rebollar, como ya lo mencionó, y el doctor Apolo Castañeda. Tuvimos la gracia y fortuna de que la Sociedad Mexicana de Investigación y Divulgación de la Educación Matemática, la SOMIDEM, fuera la editorial que nos hizo favor de publicar este libro. Este libro es resultado de del TEMBI 9 del año pasado, en noviembre de 2022, y está conformado por 8 capítulos de libros. Aquí pueden ustedes ver a los autores de estos 8 capítulos. Entre ellos se encuentra el doctor Ernesto Alonso Sánchez Sánchez y la doctora Leticia Sosa Guerrero, los cuales fueron conferencistas magistrales en el TEMBI 9, además de otros compañeros que presentaron sus publicaciones. Como decía, el libro tiene publicación de acceso libre y fue evaluado bajo un proceso riguroso doble ciego. Aquí podemos ver al comité editorial conformado por la SOMIDEM, con la presencia de la doctora María García González, presidente de la SOMIDEM, y algunos otros doctores que conforman el comité editorial. Aquí también podemos ver al comité científico revisor, conformado por investigadores de todo el país. Incluso tenemos un investigador de Barcelona, el doctor Francisco Javier Díez Palomar, que nos apoyó también en la revisión de los capítulos, la doctora Gabriela Buendía y la doctora Landy Elena de la Universidad de Yucatán, y también de la Universidad de Baja California, la doctora Lady, así como del centro del país, como Erika García Torres de la Universidad Autónoma de Querétaro, etcétera. Como pueden ver, tenemos un grupo de revisores muy, muy bueno, incluida la doctora María Trigueros Gaisman, que es profesora de la Benemérita Universidad Autónoma de Puebla. Ahora mismo les presento, entonces, el libro tiene 3 tendencias. Yo voy a hablar de la primera, que es investigaciones sobre el profesor de matemáticas, su conocimiento y sus creencias. Fue en la tendencia donde tuvimos mayor número de capítulos, fueron 4 capítulos, los primeros 3 relacionados con las creencias de los profesores y los 2 últimos con respecto a su conocimiento especializado. La doctora Lidia, le doy la palabra para que nos comente acerca de la segunda y tercera tendencia.
Sí, muchas gracias, doctora Estela. Sí, en la segunda tendencia nosotros identificamos un análisis de la formulación de problemas matemáticos. Ahí tenemos, de los problemas de matemáticas, así le llamamos. Ahí tenemos 2 capítulos del libro que están con la autoría del doctor Ernesto Alonso Sánchez Sánchez y de Marta Patricia Velasco Romero y Josip Slisko. Ellos tratan los problemas de matemáticas desde diferentes perspectivas. Y, por ejemplo, el doctor Alonso Sánchez trata los problemas que se han planteado en investigaciones de la probabilidad y nos propone una manera de usarlos en las clases, porque estos han sido usados en las investigaciones, pero él propone una forma de usarlos en nuestras aulas. Y el siguiente capítulo del doctor Josip y Marta Patricia, ellos hacen una reformulación de los problemas para analizar si estos tienen un mayor éxito en la resolución. Y la tercera tendencia que identificamos son de actividades innovadoras para el desarrollo del pensamiento matemático. O sea, ya son propuestas para aula que pretenden desarrollar el pensamiento matemático de alguna manera. Por ejemplo, la primera es el razonamiento proporcional de alumnos de telesecundaria, y el segundo capítulo de esta tercera tendencia es un acercamiento al estudio del cambio y la variación en la ejecución de una melodía. Allí ellos conjugan a la matemática con la música para estudiar el pensamiento variacional, así que todos son muy interesantes.
Muchas gracias, doctora Lidia. Pues los invitamos a leer este libro que la SOMIDEM nos hace favor de publicar, y los invitamos para que presenten sus capítulos de libro para lo que será el nuevo libro de Tendencias 2023. La convocatoria se hará el próximo mes de diciembre y les daremos unos meses para que puedan preparar sus manuscritos y poderlos enviar para que también puedan ser parte del libro Tendencias en la Educación Matemática 2024.
Sí, exacto. Muy bien. Bueno, gracias, doctora Estela. Pues aquí estamos tres de los miembros del comité organizador, Sergio Rubio-Pizzorno, y ahora se agrega el doctor Josip Slisko. Muchas gracias por estar. Nos hace falta el doctor José Antonio Juárez López, quien no pudo estar. Y estamos pues aquí los cuatro para agradecerles a todos el haber estado presentes en las actividades de este 10º taller internacional, que está cumpliendo, pues, como ya lo pusimos en el número, sus 10 años. Y le agradecemos bastante a la comunidad GeoGebra latinoamericana a través de la representación del maestro Sergio, quien también está en los controles de esta cabina, y a todos los que colaboraron en su organización. En el comité organizador también está la maestra Elizabeth Martínez Banfi y la maestra Mónica Macías, ella a cargo de la página donde ustedes pudieron encontrar toda la información y que estuvo haciendo todos los ajustes necesarios, y la maestra Elizabeth Martínez Banfi elaborando las constancias y siempre a tiempo. Y por otro lado tenemos al comité organizador estudiantil. Ahí ustedes pueden ver en la página que tenemos estudiantes de la maestría y del doctorado en Educación Matemática, y quiero agradecerles muchísimo porque tuvieron una disposición siempre al máximo, inclusive pues para resolver los problemas urgentes. Ahí estuvieron siempre. Ninguno de ellos nos falló. Y pues mencionar ya finalmente que en los talleres y en las ponencias que se presentaron, tuvimos participación de personas de otros países y cada vez se siente más la participación de ellos. Hay que aprovechar sus experiencias y lo que nos traen estos colegas que hacen investigación en la educación matemática, porque traen muchas veces otra visión, pero en otras ocasiones nos damos cuenta de que andamos por lo mismo, nuestra preocupación es la misma. mejorar las clases de matemáticas, fomentar el aprendizaje de ellas, el razonamiento matemático, ¿no? En los talleres mayormente tuvimos personas de nuestro país, bueno, el propio maestro Sergio Rubio, que es de Chile, pero está trabajando aquí haciendo su doctorado en México, pero también de nuestra propia universidad, de la Benemérita Universidad Autónoma de Puebla, estuvieron ponentes, pero la doctora Flor, por ejemplo, y el doctor Jesús Romero, de la Universidad Autónoma de Guerrero, y de Lima, la maestra Daisy, que también impartió un taller, y esta vez un invitado de lujo que estuvo con nosotros, el doctor Luis Moreno Armella, quien es SNI 3 aquí en México, también pues muy amablemente nos dio un taller. Y en las ponencias, pues aquí están los talleristas, para que no se me olvide ninguno, ¿verdad? Ahora el doctor Orozco ya en la universidad, en el Tecnológico Nacional de México, Campus CIDED, ¿no? Paco Anaya, que es nuestro egresado de la maestría y actualmente estudia el doctorado, y Modemar Campos es actualmente estudiante de doctorado de nuestra institución. Aquí están todos los nacionales que ya había mencionado, ¿no? El doctor José Antonio Juárez, el doctor Josip Slisko también. Y en las ponencias, bueno, no sé si lo vas a poner también, Sergio, pero fueron 39 ponencias en esta ocasión y tuvimos la participación también de ponentes de diversas partes del país y algunos internacionales también. Yo creo que para no alargar mucho esta clausura, pues solamente me resta agradecerles a todos ellos y a los que estuvieron acompañándonos. Esperamos que lo hayan encontrado muy productivo, que hayan aprendido bastante. Ahora le doy la palabra a mis compañeros para que den un saludo a quienes nos están mirando. Doctora Estela.
Gracias. Yo quería resaltar las 5 conferencias que tuvimos este año, particularmente el trabajo de la doctora Edelmira Vadillo de la Universidad Autónoma de Barcelona, que estuvo muy interesante con un estudio de ingeniería didáctica, el doctor Armando Aroca Araujo, que nos planteó todo el trabajo que realiza alrededor de la etnomatemática y el semillero que tiene ahí en la Universidad del Atlántico, la doctora Benilde Romo Vázquez, que también con la teoría antropológica de lo didáctico nos dio una excelente conferencia. Ella fue editora de la revista Educación Matemática hace algunos años. El doctor Ribeiro de Brasil, una excelente conferencia el día de ayer, y ahora con la ponencia de la doctora Ljerka Jukic, perdón si no lo pronuncio correctamente, de Croacia, una excelente conferencia también sobre creatividad. Espero que estas conferencias y todas las actividades que se realizaron en el TEMBI nos motiven a seguir trabajando en este campo de la educación matemática y que hayamos tenido aprendizajes significativos. Gracias.
Doctora Slisko, ¿gusta decir unas palabras?
Yo quiero expresar mi satisfacción con el taller que hemos tenido precisamente sobre el pensamiento creativo. Lo que me sorprendió era gran actividad de los participantes con ideas interesantes. Lo que me encanta, y esto me da una certeza de que hay mucho espacio para promover la creatividad entre los alumnos. Ahora espero de que hagan una pequeña investigación en campo, aplicando 2 acertijos con los alumnos, y estos 2 acertijos tienen importancia porque son parte de unas pruebas de pensamiento creativo de psicólogos. Guilford usa este tipo de acertijos como Cantona muchos años atrás, 1940. Fue a lo mejor la posibilidad de que hemos usado grupos de Facebook para en tiempo real tener diferentes soluciones de los participantes. Me encantó, encontré varias ideas que me sorprenden a mí, y yo siempre digo, la educación no es cuando maestro enseña a los estudiantes qué hacer. La verdadera educación cuando maestro como yo aprende de los estudiantes o de los participantes de su taller. Entonces agradezco mucho a todos que han participado en el taller, y espero que hagan una bonita microinvestigación para merecer la constancia. Así entendí que es el proceso para dar constancias, aunque yo podría dar en este momento constancias por su activa participación. Impresionante participación. Gracias. Y una pregunta para Lidia. No sé, como no era ponencia, ¿sería posible hacer como un capítulo o proponer un capítulo reportando lo que realmente pasó en tiempo real y en esta investigación posterior del taller?
Sí, así es. La convocatoria que lanzamos es también para los que presentaron algún taller.
Perfecto.
Los que presentaron algún taller, los que presentaron conferencia, plenaria también, y para los ponentes. Todos pueden participar en la escritura de un capítulo del libro.
Es todo lo que quise decir. Me encantó, otra vez enfatizo la participación en el taller.
Sí, muchas gracias. Maestro Sergio.
Pues muchas gracias y buenas tardes a todos y a todas. Y yo, para ser muy breve, pues agradecer por un año más de la confianza de la doctora Lidia y de todo el comité organizador del TEMBI, de confiarnos, ser parte de este comité organizador del TEMBI a la comunidad GeoGebra latinoamericana, para seguir afianzando estos lazos académicos, no solo a nivel nacional, sino que a nivel internacional. Así que a través de la difusión que le dimos al evento por nuestros medios digitales y también la participación académica. Así que agradecer a Alex, ¿cierto? A José Alejandro López Rentería y a Yecenia Méndez, que ella es nueva integrante de la comunidad de parte de Colombia, que ellos estuvieron a cargo de los equipos del diseño, de las imágenes, de los banners y de la difusión en redes sociales. Así que en nombre de ellos, agradecerle al resto del equipo, y también mostrar que pues aquí en los comentarios hay muchas felicitaciones, que las personas están muy, muy, muy contentas con todo lo que se hizo en el TEMBI. Incluso unas sugerencias, por ejemplo, hay que esperen que el próximo año sea presencial.
Sí.
Y algunos comentarios ahí un poco más extensos que otros. Así que eso quiere decir que pues, fue todo un éxito esta 10ª edición, este cumpleaños número 10 del TEMBI. Así que gracias totales.
Muchas gracias a todos. Gracias por poner los comentarios, porque ahora no tuve el cuidado de poner la transmisión en YouTube y los estaba extrañando, pero ya los veré después. Bueno, pues sin más, aquí reunidos declaramos la clausura y declaramos finalizados los trabajos y todas las actividades del 10º Taller Internacional, Tendencias en la Educación Matemática basada en investigación. Muchas gracias a todos y hasta la próxima.